This is 1033, review for test 4, part 2. Question 7. We're going to add these two rational expressions. Our first job to add or subtract is to find a common denominator. So you have to cover all the types of pieces that are there. For the numbers, we are going to need a 5. For the u's, we only have one u, so we'll need a u. And we will need a v squared for our common denominator. So we need that under each piece. I'm going to bring down what I have, and then we'll put on the missing pieces. All right, so when I check this denominator, I have the 5, I have the u. It is missing the v squared. It goes on numerator and denominator. And that gives me 6v cubed over 5uv squared. I'm going to bring down the next one, bring what I have, and put on the missing part. So check the denominator. You have the 5, you're missing the u. Goes on numerator and denominator, and that gives me 2u squared over 5v squared u. Now, I will keep the common denominator, 5v squared u, and combine the numerators. They're not like terms. They can go on the same line. And we can see if anything would factor out to reduce. We could factor out a 2, and that leaves 3v cubed plus u squared. But it doesn't reduce. Since it doesn't reduce, you could have left it at the previous step. But you're supposed to think about this, so either of these two would be okay. Problem 8, we're adding fractions, so we will have to find the LCD. For our numbers, we have a 3 and a 2. They're both primes, so we're actually going to need them both. So 3 times 2 will give us a 6. You will need the x cubed. So we'll bring down what we have, and we'll put on the missing part. So our first fraction is missing a 2 to get the 6, and it's okay with the x cubed. So we have 8, 6x cubed. For our second fraction, bring it down, and we have 2. We would like 6x cubed. So it is missing a 3x cubed. Put it on numerator and denominator, and that gives us a 9x cubed y over 6x cubed. Now, keep the common denominator and combine the numerator. They're not like terms, so there is nothing you can do to combine them, and you are not able to reduce. For problem 9, we're adding fractions. We check our denominators. These denominators will not factor, and they are totally different. So we are going to need them both for a common denominator, an x plus 2, and a 3x plus 1. So we'll bring down what we have. And the first fraction is missing the 3x plus 1. Put it on numerator and denominator. And we'll bring down the second fraction. It is missing the x plus 2. Put it on numerator and denominator. Now, if you remember, numerators will have to combine, so they need to simplify. The denominators, when we add and subtract, we just keep once we get them common. So we can keep it in either order, but we don't have to multiply those out. So I'm just going to keep the first order. right? Numerators I have to multiply out. So I have to distribute here. 2 times 3x is 6x plus 2. And I'm going to combine over here. This is a positive 2 to distribute. So plus 2x plus 4. We can clean up there and we get 8x plus 6 over x plus 2 times 3x plus 1. We could factor a 2 out of the numerator. So if we take it out, that leaves 4x plus 3 over x plus 2 times 3x plus 1. It did not reduce, so either answer is correct. Problem 10, we're adding fractions. These fractions have opposites that are denominators. You can actually use either one. So I'm going to go ahead and use the r minus 6 for my LCD. That means my first fraction is okay. And I'll bring down the second one. I'm going to work on it. I will multiply by a negative 1. So now I'm multiplying by it rather than factoring out. So I have to do numerator and denominator. So first fraction stays the same. This one will give me, I can put plus here if I want, but it's a minus 3r over, and this is a negative 6 plus r, or r minus 6. Now I can combine. Keep the common denominator and combine on the numerator. You have a negative 3r plus 6. We can factor out a negative 3. And that will leave us an r minus 2 over r minus 6. And it does not reduce. There is nothing here that will reduce, so it could have been left in the previous step. For problem 11, we're adding fractions. These actually already have the common denominator, so we can go ahead and keep that common denominator, put it in the answer, and combine the numerators. But they are not like terms. I'm going to just put the variable term first. We could try to factor to see if we can reduce. We can take a 5 out of the numerator, and that leaves n plus 5. And it will reduce with the denominator. So we can divide out the n plus 5, and it leaves us just 5 for our answer. Problem number 12, we're going to subtract fractions. We're actually going to have to factor these denominators before we can figure out the common denominator. Our first denominator is difference of squares. So x plus 4, x minus 4. The second denominator is a trinomial, 2 sets of parentheses, like signs both plus. And 5 times 4 will multiply to give 20 and combine to give a 9. So for our LCD, we have to cover every type of piece. So the x plus 4 is in both. We'll only need one of those. We will also need an x minus 4. And we will need an x plus 5. I'm a little short on room, so I'm going to squeeze it at the front. We will need all 3 pieces. So I'm going to bring down what I have in factored form, and then put on the part that's missing. So this first one is missing the x plus 5. And the second fraction, I'm going to bring down what I have in factored form. And put on the part that's missing, which this time is the x minus 4. Now, remember with addition and subtraction of fractions, once you have that common denominator, you're going to keep it. So I don't have to multiply it out. I do have to multiply the numerators because they're going to combine. So I have 3x plus 15. I have a minus 8, which is going to distribute to this parentheses. So that will be a minus 8x and a plus 32. And now we'll combine. So we're going to have a minus 5x plus 47 over this denominator. And that numerator does not factor, so this is as far as we can go.